In the last couple of videos, we focused on nomenclature of carboxylic acids and carboxylate salts. Now in this video, we are going to turn to the IUPAC system of nomenclature for ester molecules. Esters are very common flavors and fragrances, and that's why I have this image here of a tray of various flavors and fragrances. One example of a common ester that is frequently used as a minty flavor and fragrance is a compound known by its common name most frequently of methyl salicylate. Methyl salicylate is produced by the wintergreen plant and also produced in a synthetic chemistry lab and is used both for its analgesic properties and for its fresh minty taste and flavor. Let's go ahead and look at IUPAC nomenclature system for esters. Naming of esters is a bit distinct from naming of carboxylic acids and carboxylate salts like we did in the last couple of videos, but I know by now you can manage this. So alkyl alkanoate is the template for the name that we will use for an ester. For example, an ester could be referred to as methyl ethanoate, for example. How do we come up with the name of the alkyl and the alkanoate? By dissecting the structure of the ester. Esters, by definition, must have a carbonyl group directly bonded to an oxygen. That oxygen has to be directly bonded to an alkyl chain or a ring or something like that. So I'm going to call that an OR prime group. Over here, on the left of this particular structure, I'm going to put an R group. Our R groups represent our carbon chains or carbon rings. Now, in naming an ester as an alkyl alkanoate, the alkyl part of the name corresponds to the structure of the R prime group over here. So this refers to the alkyl part of the name. So if this was a 3-carbon chain, just a straight chain, we would call it a propyl alkanoate. And the alkanoate part we would, of course, fill in with whatever the structure is of the rest of the molecule here. So alkyl refers to the structure of whatever group is bonded to the oxygen. So the alkyl part of the name again is whatever's bonded directly to the oxygen. That's going to be an alkyl group of some sort. The R group here that forms the name alkanoate is going to refer to the carbon chain of the R group or carbon ring or whatever structure we're dealing with there, along with the carbonyl group. So everything I'm showing in red here will correspond to the alkanoate name. So the alkanoate part of the name corresponds to the carbonyl group and whatever the structure of that R group is that's directly bonded to. I'm going to put a squiggly line over here to indicate it connects to something else, specifically that oxygen of the ester group. But what we're naming when we talk about the alkanoate is referring to the structure of the carbonyl and whatever that R group identity is. So this part of the name is what we'll fill in with our term alkanoate. We will number here, when thinking about numbering of where branches are located, number from the carbonyl group being position number 1 of the chain there. And going so on and so forth to carbon 2 and whatever else that might lead us toward. So let's do an example of taking this type of nomenclature and applying it. So I'm going to go ahead and draw out the structure of an ester molecule here. Like so. Now to name this molecule, we will go ahead and start by naming the alkyl group, which I'm going to highlight and bracket off in blue here. Our alkyl group is this 3-carbon group with the connection point there at the middle carbon, meaning this is called an isopropyl group, based on the nomenclature we've learned before for these branched 3-carbon groups. Now, on the other side, we have our carbonyl group directly bonded to our chain here. There are 3 carbons in total in that chain, including the carbonyl carbon. 1, 2, 3. And so we would name that propanoate. So the full name for this particular molecule, plugging those two together, is isopropyl followed by propanoate. And the main thing to remember here, and the main thing that I get confused about, and others probably do as well, is that when naming this, you have to remember that the alkyl part refers to the group over here that's directly bonded to the oxygen. The alkanoate part is derived from the carbonyl group and everything over, including the carbonyl. So keep that in mind as you're naming these types of molecules. Let's do another example problem here to make sure that we have this technique down. And you're welcome to hit pause here, give this a try on your own, and then hit play to give it another shot with me. So let's go ahead and come up with the name for this molecule. As we follow our template, we're going to start by naming the O alkyl group. That is the alkyl group that's directly bonded to the oxygen. So this 6-membered ring is called a cyclohexyl group, HEXYL, to denote the format that we're using here is our alkyl groups ending with YL. 6 carbons in a ring, cyclohexyl, and then we'll name the other portion of the molecule, that is the carbonyl group, onward as our alkanoate group. And this specific alkanoate group we number starting from the carbonyl group, finding the longest carbon chain. That's 4 carbons. So 4 carbons is going to take on the parent name butanoate because we have 4 carbons in the chain. And using this template of alkanoate, the O8 part there refers to the fact that it is that carbonyl and oxygen of the ester. And at position number 3 of that chain, we have a special extra guest here. We have a methyl group. And so we need to refer to that in our name as well. So we'd call this 3-methyl butanoate as the name of that alkanoate group. So plugging those two together, we have cyclohexyl and then a space, and then 3-methyl butanoate as the full IUPAC name for this particular molecule.